Hi everyone, in this video we will see how we can build a chatbot using Llama 3. So first up we need to install few libraries which include bits and byte. That's basically used for the quantization of our model because we cannot load our model weights into the free GPU resources of Colab. So coming next we will install the transformer library and similarly the accelerator library. So once we have installed all these relevant libraries, so we will install the Hugging Face library as well. So basically this is a Hugging Face hub where we can download our model. This is required because Llama 3 and Llama 2, although they are publicly available, but we first need to register to their site to get the access to download these model weights. So that's why we need to install Hugging Face library, and then we will log in to this library using our Hugging Face tokens. Once we install all these library, we will import the torch, and from transformer we import auto tokenizers, auto model for casual LM, bits and byte configuration, and text streamer. We will discuss it in a bit. So first we will configure the model ID. Here it is meta llama 3 8 billion instruct. So if we can see, so this is basically a model ID. Instruct is basically used for the chatbot because it's fine-tuned in that way where we can have a conversation with a chatbot. And next up we have bits and byte configuration. So here we are loading our model into 4 bits because if we load into normal, like for 8 billion, if for example we have 32 bits for 8 billion model, and we divide it by 8, so it's almost we can see 256 divided by 8 means we need 32 gigabytes of GPU to run the 8 billion Llama 3 model in its original configuration. But because we have only 15 gigabytes of GPU RAM, so we have to quantize in a way that we can actually load our model into this RAM. So for that we are loading into 4 bits. So if we do the math, 8 multiplied by 4, so 8 is our 8 billion model and 4 is the bits, and we divide it by 8 for the conversion of bytes and bits, and it will eventually comes to 4 gigabytes of RAM. So this is the RAM, GPU RAM that we need to run this model in the free Colab version, and we will see in a bit that it actually takes 4 gigabytes to run this Llama 3 model. And similarly these are other configuration for the bits and byte. So after that we have a tokenizer. So basically tokenizer help us to convert our text into the numerical representation that eventually help the model to understand, and it will work that way. For that we have this model variable where we are using basically auto model for casual LLM function. So basically this whole line loads the pre-trained model for casual language modeling. That means it is used for text generation, and similarly we have some specified quantization configuration in it, and the device map argument ensures that model is loaded on the first available device. That's basically GPU in this case. Similarly these two lines are basically used for potentially faster generation, where we are using the cache and model evaluation mode to generate our text faster. So once we run this command, it will basically download the model's weight into quantized form into the GPU of free Colab version. Yeah, so once it loaded the weights, as we can see, it only took 5.6 gigabytes of GPU RAM. Normally it takes from 4 to 5, but here it has taken 5.6 gigabytes of the RAM for the 8 billion parameters model of Llama 3. Next we have some configuration in which we have to interact with the model for the inference. So first here we can see a message. It's a list that contains the dictionaries, one for the system prompt and other for the user prompt. And similarly this tokenizer.apply chat function, it basically processes the conversation history. It kind of add the special token to differentiate between user and system messages and potentially insert context for the model. And similarly In here is the terminators defines when exactly model need to stop generating the text. Like this is the end of token or end of sequence, so here we are defining that. And similarly this model dot generate, so we will pass our input IDs that we have defined here. Similarly max token size, that how much we want the output to be, so here we have defined 256, so it will generate 256 max tokens. And similarly we have defined our terminators as well. And here is the temperature and top piece. So temperature basically controls the randomness of the sample. For example, a lower temperature makes the generation more conservative and likely to stick to the conversation. If we increase the temperature size, so it will start generating random stuff. And similarly top P is like control how likely the model will pick the most probable tokens at each step. And for response, this line basically extract only the generated response, excluding the original conversation history or the prompt that we have passed to the model. And similarly here we will decode our response because it's originally in the form of tensors that we cannot understand, so basically we have to convert into the human like text. So here first we are defining that what are you, like you are a personal chatbot who respond in professional tone and explain things clearly. So this is kind of a system prompt where we are defining its functionalities, and then it's a user prompt where we are asking our question like who are you and what you can do. Once we run this and it will start generating answer to our QD, that is who are you and what you can do. So it will generate like this response, like I'm delighted to introduce myself, I'm personal chatbot, because we have defined its functionality in the system prompt. And similarly it answered our query like this chatbot can do. So we can see it can help us in general knowledge, language translation, and a lot of things. So far our chatbot is up and running and we can have conversation with the chatbot, but we need a more UI based chatbot. So for that we will be using Streamlit. So first step, we will install Streamlit into the Colab, but there's a catch. Colab cannot run Streamlit into its environment because it runs on 8501 port. So for that, we will use npx to route our traffic to this particular port. So for that, we in the first step run this command. It will give us IP, and similarly we run this command. So basically it will give an external link where we'll paste our IP and it will route our traffic. So once we click that, it will give us this tunnel. So here we will pass our IP and we click to submit. So it basically load our Streamlit app. So here is the Streamlit app where we have converted our code into functions. Like here we can see get tokenizer model where we are getting our tokenizer and model. This is by the way same code that I have shown above. And if you're someone who is not familiar with the Python or stuff, so I'm sharing this code. You can actually get this code and use this, or you can either modify it according to your own needs. So next we have our main function where we are defining the title and similarly some sidebars. And here's a function to generate our model response. So if you can see, then this is basically the same code that I have shown above. So just converted into a function so that we can pass our values and actually have a conversation in the Streamlit app. So similarly here is the display chat message. So this is pure Streamlit code from here to till end. If you want me to make a detailed video on Streamlit, like how it works and how we can do some changes, do let me know. I will make a separate video, but for this context you understand that this basically block generate display our messages. This block basically asks the user for the input, and this block basically generate our responses. And this is a button that basically clear our history. So yeah, moving towards our Llama3 chatbot. So here we can see here's a system prompt, and here we can enter our message like who are you and what you can do. So if you just hit enter, so it will start like thinking and doing its stuff, and eventually it will get back to us with the result. So basically it has generated the answer. As you can see, I'm Llama and large language model trained by Meta, etc., and it can do these kind of things. So if we see about the system prompt, like I mentioned earlier, this is basically used to change the behavior, like how model should behave. So if you can say like act like Abdul's personal chatbot and reply in professional tone. So basically we are defining its behavior, like how it should behave. So if we ask the same question again, so we can see that response will be quite different. Here we go. So as we can see, the response is completely different. So right now it's nice to meet you, I'm Abdul's personal chatbot, because we have defined its functionality in the system prompt, and similarly the rest of the answer like that way. So that's the benefit of system prompt. Similarly, we can define anything like act like a funny chatbot, and if we ask the similar question, so it will behave totally different. As we can see in the output, like now it's acting like a funny chatbot. So yeah, that's it with today's video, where we have seen that how we can build a chatbot with few steps and within few minutes. Thank you so much everyone, have a nice day.